Hello, it's Keith here, and this is lesson 45 of the platform-specific series of my Z80 tutorials. We're going to be looking at the Elan Enterprise this week, and we're going to be looking at the 256 colour mode. I find this quite interesting because essentially the Elan Enterprise mimics the Amstrad CPC's colour modes up to this point, in the fact that it's got the same 2 colour mode, the same 4 colour mode and the same 16 colour mode. But unlike the Amstrad CPC, the Enterprise has this 256 colour mode as its sort of grand finale in its mode range. Now, in the same way as the 16 colour mode has half the horizontal resolution as the 4 colour mode, the 256 colour mode has half again. So the 320 pixel wide 4 colour mode compares to the 160 pixel wide 16 colour mode, and when you get to 256 colours you're down to just 80 pixels wide, which gives some very chunky pixels. But for 256 colours it may be worth it. It just depends what you want to do. So we're going to have a look at this today. It's very easy to turn on. We just take our existing code and we just change the 2 bits that define the screen mode from a 1 or a 2 for 4 colour or 16 colour mode, and we change it to a 3, and that turns on 256 colour mode. Unlike the other modes which use some kind of palette, 256 colour mode uses no palette at all. This is perfectly logical because the palettes on the Enterprise are defined by 8 bits, so we effectively have the entire palette range on the screen all the time anyway. Each pixel in this mode defines its own colour, and it does it with 3 red bits per pixel, 3 green bits per pixel, and 2 blue bits per pixel. So that's how the 8 bits make up the colour. Now obviously this means there's more red and green definition than blue definition, but it's still pretty good, and as I say, this really gives us some quite nice capabilities. Okay, well, let's actually see the example code running today and we'll have a look at what we're doing. So here we've got this nice Enterprise screen here. It's effectively the Enterprise keyboard, and then because this is so easy, we're going to extend this and we're going to look at this very, very narrow font. I've created this 4 pixel wide font, and I think this could be useful for you if you're needing to get an awful lot of text on the screen, or equally if you've not got much memory for your font, because our normal font uses 8 bytes per letter. This one is effectively combining 2 lines of our font per byte, so we are just using 4 bytes per character. So maybe it's going to be useful for you for systems with very little memory like the computer's Lynx, or maybe for a very small screen like the Game Boy. Anyway, we're going to look at that as an addition to our 256 colour mode, and we'll see all that later. So how did I make this screen? Well, I took a screenshot, a photograph I had taken, and I loaded it into Sprite Editor. You can see Sprite Editor here. I extended this to support 256 colours. You can see we've got a 256 colour palette here, and what we can do here is we can actually load in the Enterprise default palette using this option here. So you can see here, this is how we can select. This is the Enterprise palette. Also the MSX2's 256 colour palette. They both use the same colour definitions, so that was quite handy. Now you'll notice the pixels are very small here, and they shouldn't be. They should be quite chunky. We need to change the view mode to this option here for 80 by 200 in 256 colours, and you can see now we've got an accurate representation of what it's going to look like on screen. Then finally we can just go to Z80 Elan Enterprise File and use this Save Raw Bitmap option, which will save in whatever mode we've got displayed on the screen. So because we've now got 256 colour mode, we will export a file that is valid for today's example. So that's how we do it. As I said before, the way of changing the screen mode is just done by the 2 bits down here. Where are they? Here they are. So if these 2 bits are set to 1, it will select 256 colours. If they were set to 102, it would be 16. 01 would be 4 and 00 would be 2. So that's all we do. The palette does not matter in this case, so I've set all of the colours to 0 here just to prove that point. As I say, the bits of each byte of the screen memory will, as I said, the bits of each byte of screen memory in this layout will define the colour that is the result. So that's how we do it. Okay, so what about our 4-bit per pixel font? Well, I've made this in Sprite Editor as I usually do, so let's load that up. So if we just go here, load recent, font low res. So this is our font here, and if I just zoom in, you'll see that we've actually got 2 different characters in each byte here. So if we were going to show character 34 here, we would need to use the high nibble. If we are using character 35, we need to use the low nibble. So we're going to have to alter things a little bit just depending on which character we're trying to show. So we've got a print string routine here, I use this a lot in my tutorials. If you've seen these tutorials before, you'll know print string uses print char. So it's the print char routine that's all that's changed in this example. So let's just find it. And here it is. So as in all of our cases, we are first calculating the memory address of the font character that we want to show. We're skipping one bit here because in this case we do not want that last bit of our character number because there are 2 characters per byte now, and we're altering our shifting here. We're multiplying by 4, not 8 this time. Then we are loading in our bitmap font as before. We're calculating our screen address. Each character is 4 pixels wide and each pixel on the screen is a single byte now, so we're just multiplying by 4 there. We're calculating our Y position and doing get screen pos here as we usually do. Now we're loading in from our source font definition here. This is the bitmap font that I exported, and we're storing that into C. We're then restoring the character that we originally wanted to show. This function is called with the accumulator, selecting the character we want to print to the screen. We're doing this at this point because we want to branch out depending on the low bit. Remember, we ignored the low bit here because we're sharing the font with 2 characters per byte, but now we need to know which one we're looking at. If we are doing the high nibble, then we are just going to effectively take the top 4 bits, but if we're doing the low nibble, then we are going to have to take these 4 bits and shift them into here so that our code still works. And that's what we're doing here. We're just branching over to here. Then we're going to use 4 bits here. We're shifting 1 bit off each time, and we're loading them into 4 separate screen bytes because, as I say, each byte of the screen memory is a single pixel. So doing this will set 1 pixel of our screen to the first color in the palette there. So that's what we're doing. And then we just repeat here. We increase our cursor position. Our screen's just 20 characters wide now because it's so low res, which is why we need this narrow font. But that's all there is to it. So I thought this was worth discussing. I think the 256 color mode is surprisingly simple, but it's a lot of fun to see such an old machine showing such impressive graphics. Now let's just fire it up again. I do like to see it. So yeah, so that's what we can do on the Enterprise if we want. You know, maybe you want to have a nice loading screen or something. Certainly impressive to see. Of course, as well, as I've said before with the Enterprise screen is defined by the LPT here. So this actually defines the layout of our screen. So we can have screen mode changes at different points within our screen, and that's all done in hardware. So you could have a game like a text adventure where the bottom half of the screen is mode 2, the top half of the screen is in this 256 color mode if that's what you wanted to do. And you can actually make the screen physically wider at the cost of more memory. So you could make this use more of the horizontal width of the screen, like the overscan effect on the Amstrad CPC if you wished. Anyway, that's all I really wanted to cover in this lesson. I thought I'd show you this interesting mode. That it would have been unfair to the Enterprise not to cover it because, as I say, as a person who grew up with the CPC, I found it quite fascinating. Hope you've enjoyed this anyway. Thanks for watching today, and goodbye. If you enjoyed today's video, please check out my new YouTube channel known as Chibi Ackerman's Live. This is going to be a live streaming channel, and it's going to be some more casual content. It will be me streaming some of my programming sessions, me playing games and chatting along. I'm going to try and really do a lot of technical content in there, try and explain things as I'm playing games, you know, talking about the hardware or while I'm programming. And also I'm going to try and interact with the chat a lot. So if you really enjoyed today's lesson, then maybe you want more content and that will give it you. Equally, if you didn't enjoy today's lesson, if it was too hard for you, if you found it confusing and you want something a bit lighter hearted, then it might be interesting to you as well. Though I guess you've probably already clicked off if you didn't enjoy it because 95% of my viewers give up after about 2 minutes. But either way, thanks for watching and goodbye.